This is Looking Forward for Wednesday, the 1st of April, 2015. As you get ready for class on Wednesday, I'd like you to read sections 30.5 and then 31.1 through 31.3 of your book. I'd like you to think about the following couple of questions. First of all, consider a wire. It's got some current traveling to the right. We know that it has a magnetic field. The magnetic field comes out on the top, goes in on the bottom. Now imagine that wire runs into a capacitor and then keeps on going. We know on the right that there's some magnetic field as well. But what about in here? What about where the capacitor is? It sure looks like there's no current, and therefore there should be no magnetic field. And yet the magnetic field should be continuous. We have some here on the left, we have some here on the right. What about the magnetic field in the middle? More importantly, if the magnetic field is continuous, why is there a magnetic field hanging out there in between? The second question has to do with what happens if I were to take a solenoid and combine it with a capacitor. Now, we know when we did the potential difference across a solenoid, the EMF, that it was proportional to the rate at which the current changed. We also know here across the capacitor that the potential difference for the capacitor was proportional to the charge. If we put those two things together and do a loop rule, what we get is a differential equation that looks something like this. Where L is some constant, and di dt is simply the second derivative of the charge with respect to time. Do you recognize that differential equation? In fact, you should from last semester. What is it? What physical system does this correspond to? What does that tell us about how the charge varies as a function of time? Now, if we put those two things together, what does that tell us about what happens when we have changing electric fields and changing magnetic fields together? Is there something interesting that can happen when we have both of those going at the same time? We'll talk about that and more when we get together on Wednesday. See you then.